A logic family in computer engineering refers to a group of electronic logic gates built using various designs, sharing logic levels and power supply characteristics. These families were commonly standalone components hosting basic logic functions that could be interconnected to form systems or link more complex integrated circuits. In the realm of VLSI integrated circuits, a logic family can indicate the methods employed to implement logic, appearing in central processors, memories, and other intricate functions. Some logic families employ static approaches to reduce design intricacy, whereas others, like domino logic, use clocked dynamic methods to enhance compactness, decrease power usage, and minimize delays. Before the advent of integrated circuits, solid-state and vacuum tube logic systems existed, but lacked standardization and interoperability compared to integrated circuit devices. The prevalent logic family found in modern semiconductor technology is metal oxide semiconductor, MOS logic, prized for its attributes of low power consumption, diminutive transistor dimensions, and elevated transistor density. The packaged building block logic families are categorized based on their historical introduction. These categories include resistor transistor logic, RTL, direct coupled transistor logic, DCTL, and direct-coupled unipolar transistor logic, DCUTL. Additionally, there is resistor-capacitor transistor logic, RCTL, emitter-coupled logic, ECL, positive emitter-coupled logic, PECL, and low-voltage PECL, LVPECL. Other families are complementary transistor micrologic, CTUL, diode transistor logic, DTL, complemented transistor diode logic, CTDL, and high-threshold logic, HTL. There are also transistor-transistor logic and TTL, metal oxide semiconductor, MOS logic, P-type MOS, PMOS logic, N-type MOS, NMOS logic, depletion load NMOS logic, high-density NMOS, HMOS, complementary MOS, CMOS logic, bipolar MOS, BiMOS logic, bipolar CMOS, BECMOS logic, integrated injection logic, I2L, and gunning transceiver logic, GTL. RTL, DTL, and ECL originated from early computer logic circuits that were initially constructed using discrete components, like the Phillips-Norbit family. PMOS and I2L families, while once in use for specific custom large-scale integration circuits, are now considered outdated. Examples of PMOS devices can be found in early digital clocks and calculators. Notably, ECL, TTL, NMOS, CMOS, and BiCMOS are the enduring families in common use today. ECL is preferred for high-speed applications despite its higher cost and power consumption, while NMOS logic finds its place in VLSI circuits like CPUs and memory chips. Presently prevalent logic gate ICs derive from ECL, TTL, CMOS, and BiCMOS families. Resistor transistor logic, RTL, is a class of digital circuits utilizing resistors as input networks and bipolar junction transistors, BJTs, as switching devices. The Atanasoff-Berry computer employed resistor-coupled vacuum tube logic circuits, akin to RTL. Early transistorized computers, such as the IBM 1620 in 1959, adopted RTL using discrete components. Fairchild Semiconductor developed a family of basic resistor-transistor logic integrated circuits for the Apollo guidance computer in 1962. Texas Instruments swiftly followed suit with its own RTL family. Another iteration, resistor-capacitor transistor logic, RCTL, boasted increased speed but lower noise immunity compared to RTL. Texas Instruments produced this under their 51XX series. On the other hand, diode transistor logic, DTL, functions with a diode network for logic gating, e.g., and transistors for amplification. Initially used with vacuum tubes in the 1940s, diode logic found its place in early electronic computers like ENIAC. DTL made its debut in the IBM 608, the first all-transistorized computer. Signetics introduced the first family of diode logic integrated circuits in 1962. P-type MOS, PMOS logic, involves P-channel MOSFETs for logic gates, prevailing in the industry from 1960 to 1970. Conversely, N-type MOS, NMOS logic, employs N-channel MOSFETs due to their smaller size and simpler production process. Although NMOS logic was faster than CMOS initially, power consumption remained an issue during idle states. Bell Labs developed MOSFETs with a 20mm process involving PMOS and NMOS devices, with NMOS eventually being refined in a more practical NMOS process. NMOS logic was prevalent in 1970s computers but was overshadowed by CMOS logic in the mid-1980s due to technological advancements. In 1961, IBM introduced ECL, also known as current mode logic, to be utilized in the transistorized IBM 7030 stretch computer, implemented using discrete components. Following that, in 1962, Motorola launched their initial line of ECL integrated circuit devices, branded as MECL 1000, which necessitated a negative power supply. Subsequent advancements of ECL, like PECL and LVPECL, involved using a positive power supply. ECL employs an overdriven bipolar junction transistor, BJT differential amplifier, with single-ended input and limited emitter current. On the other hand, in TTL logic, bipolar junction transistors, BJTs, are responsible for executing logic and amplifying functions. The first family of integrated circuits utilizing transistor-transistor logic was introduced by Sylvania as Sylvania Universal High-Level Logic, SUHL, in 1963. Meanwhile, Texas Instruments unveiled the 7400 series TTL family in 1964. TTL technology has evolved over time, with newer versions replacing older ones. Walter H. Schottky's theory predicting the Schottky effect led to the development of Schottky diodes and transistors. Transistor logic gates constructed with Schottky transistors switch faster than those made with ordinary BJTs, but consume more power. With the introduction of low-power Schottky, LS, internal resistance values were increased to enhance speed and reduce power consumption compared to the original version. The subsequent release of advanced low-power Schottky, ALS, further improved speed and decreased power consumption. Another faster logic family, Fairchild Advanced Schottky TTL, FAST, was also launched, surpassing the speed of the original Schottky TTL. Furthermore, CMOS logic gates utilize complementary configurations of N-channel and P-channel field effect transistors to execute operations. Initially, CMOS was slower than LS-TTL, but its adaptability to battery-powered systems with simple power supplies due to logic thresholds being proportional to the power supply voltage made it favorable. The era of VLSI saw CMOS technology dominate due to its ability to incorporate millions of basic logic operations onto a single chip, paving the way for enhanced performance and reduced power consumption. Lowering the power supply voltage in CMOS chips can significantly reduce energy consumption and heat dissipation. The emergence of the 74HC standard bridged the gap between the previous TTL family and the CD4000 series of chips, combining advantages from both. Conversely, interconnecting different logic families required special techniques to align voltage levels and interface requirements. The creation of the 74HCT devices resolved the logic level compatibility issue between TTL and CMOS technologies. Additionally, there are other CMOS circuit families like cascode voltage switch logic, CVSL, and pass transistor logic, PTL, mainly utilized within integrated circuits. The BiCMOS logic family emerged as a significant advancement by amalgamating CMOS inputs and TTL drivers, resulting in a new category of logic devices. Notably, the LVT and ALVT logic families within BiCMOS gained prominence for their unique attributes. With competitors like HC, HCT, and LSTTL in the market, the necessity for enhanced logic devices that blend rapid processing speeds, low power usage, and backward compatibility arose. This demand led to the development of diverse CMOS-based technology families. Among these, some key designators include LV logic, LVT logic, which retains TTL logic levels at lower supply voltages, and the more advanced ALVT logic. The landscape expanded further to include AC ACT logic, AHC, AHCT logic, ALVC logic, AUC logic, AVC logic, CBT logic, CBT-LV logic, FCT logic, and LVC logic, LVCMOS. One notable yet now outdated inclusion was the integrated injection logic, IIL, utilizing bipolar transistors in a current steering arrangement for logic operations. The comparison of monolithic integrated circuit logic families provided insight into their varying characteristics, such as propagation delay, toggle speed, and power consumption. Highlighted families like RTL, DTL, PMOS, CMOS, AC ACT, HC, HCT 4000B, 74C, and TTL original series L, HS, LS, ALS, F, AS showcase their performance metrics and historical introductions. Moreover, the ECL families, ECL3, MECLY, 10K, 100K, 100KH, demonstrated their unique strengths in terms of speed and power utilization. Different on-chip design styles, particularly static techniques like pulsed static CMOS, differential cascode voltage switch, and dynamic logic variations such as four-phase logic and domino logic, are primarily employed in large single-chip ASICs and CPUs for specific applications.